हेलो स्टूडेंट्स, हाउ आर यू? नमस्ते। आज ये थर्ड वीडियो है, दिस इज थर्ड वीडियो, रिफ्रैक्शन एट प्लेन सरफेस, एंड इट इज़ अ वेरी इंटरेस्टिंग टॉपिक। और मेरी कोशिश है कि आपको इस टॉपिक में कुछ स्किल डेवलपमेंट कराऊं, कुछ सिखाऊं आपको। कोर्स के पीछे मत भागिए, टॉपिक का कॉन्सेप्ट क्लियर करने की कोशिश करिए। चलिए मैं स्टार्ट करता हूँ। लेट्स स्टार्ट। फर्स्ट पॉइंट इज रिफ्रैक्शन वर्ड। What is refraction? If light is passing from one medium to another medium with or without deviation, phenomena is called refraction. With or without deviation is called refraction. Okay, students? Then cause. What is the cause of refraction? Speed of light is different in different medium. It is a cause. Third point is medium word. You should try to clear the concept of the medium word. Medium is two types, rarer and denser. I am taking the example air and water. It seems to be, सभी लोग जानते हैं कि air is rarer medium and water is denser medium. But in the physics, कोई भी चीज 100% certainty नहीं होती है. There is a few laws are only universal law. After that, everything is dependent on the situation. How do we know that? How do we decide that which medium is rarer medium or denser medium? Don't say that the water is the denser medium and air is the rarer medium always. Concept is for this: speed of light is greater in rarer medium and speed of light is lesser in denser medium. By this concept, it is the first concept in the refraction topic. कि speed of light is greater in rarer medium and lesser in denser medium, then you can understand the type of the medium. I am taking the example. We know that सारे लोग जानते हैं, हम लोग जानते हैं कि when anything is passing from rarer to denser, it bends towards the normal. This is a very important question. With the help of this question, you can understand the concept of the rarer and denser medium. Sound wave passing from rarer to denser. This is sound wave passing from rarer to denser. If water means it is a denser medium, suppose it should bend towards the normal. But this is the wrong answer. We know that speed of light in speed of sound is greater in denser medium, then liquid, then gas medium. There is a two medium, liquid and gas. Speed, by this concept, speed of sound is greater in denser medium, means solid. Here is a liquid, means liquid and gas. The speed of sound is greater in liquid and lesser in the gaseous medium. And हम लोग जानते हैं, we know that in which medium speed of light or sound is greater, that is a rarer medium. By this concept, water become rarer medium and air become denser medium. So sound wave will not bend towards the normal, it bends away the normal. This is the first concept. With the help of this, you can detect, you understand which medium is denser medium or which medium is the rarer medium. Is it clear? Fourth point, What is the main benefit of refraction in our life? हम लोग पढ़ते क्यों refraction? Due to refraction, we can detect surrounding us everything very well. Like example, हम लोग क्लासरूम में बैठे हैं, पढ़ा रहे हैं, मैं आपको इसलिए देख पा रहा हूँ due to refraction. If refraction will not occur, we cannot detect anything which presents in surrounding. Always you remember, with the help of refraction, we can detect everything which exists in surrounding. Otherwise, we cannot be detected. This is the main concept of the refraction word. Okay, students? Next, in this topic, the very important topic is now I am using refractive index. Without the concept of the refractive index, the concept of light is incomplete. The first point is absolute refractive index. Absolute refractive index is equal to C upon V. Means absolute refractive index is defined as the ratio of speed of light in vacuum or air, and V is the speed of light in medium. What is the refractive index of air? We know that using this concept, speed of light in air or vacuum is C, so it becomes to 1. So always remember, speed of light in air, refractive index of air is always 1. Next one is the relative refractive index. Relative refractive index 1 mu 2. It is defined as the ratio of absolute refractive index of the second medium with respect to first medium. I mean, it is defined as the ratio of absolute refractive index of second medium and absolute refractive index of the first medium. Now, in place of mu 2, with the help of this formula, we can write C upon V2. This is C upon V1 is equal to V1 upon V2. आप लोगों ने क्लास 10 में इस क्वेश्चन को देख चुका है फॉर्मूला कि रिलेटिव रिफ्रैक्टिव इंडेक्स इज इक्वल टू स्पीड ऑफ लाइट इन फर्स्ट मीडियम एंड स्पीड ऑफ लाइट इन सेकंड मीडियम इज इक्वल टू एफ लैम्डा 1 f lambda 2 because frequency is not changes, so we can write here lambda 1 upon lambda 2. There is so many formula. With the help of this you can calculate the relative refractive index of one medium with respect to another medium by mu 2 upon v1, v1 upon v2 or lambda 1 upon lambda 2. Okay. So this is the concept of the, you should remember, these are the very important point, and it is a very helpful in the numerical. Always remember. Next point, laws. Laws of refraction. What is the laws of refraction? First point, light ray when passing from one medium to another medium, then what happen? This has the angle of incidence, this has the angle of refraction. First point is factor changes What is the factor changes with light passing from one medium to another medium? Speed, wavelength, and maybe direction also. Does not changes. Frequency. Frequency means color. And phase. These two, factor changes and factor does not change when light passing from one medium to another medium. Next one, हम लोग सारे लोग जानते हैं, इंसिडेंट रे, रिफ्रैक्टेड रे, नॉर्मल लाई एट द सेम प्लेन. Next point, that is known as the also Snell's law. Mu into sin I is equal to constant. What is the meaning of this? Refractive index, and it is defined as the product of refractive index and sine of angle of incidence at a point in a medium is always constant. This is known as the Snell's law, and it is the main point of the laws of refraction. Means we can write here mu1 into sin I1 is equal to mu2 into sin I2. Always you remember, this is the very important law. When light is refracted, deviated from one medium to another medium, always use this formula. Mu1 into sin I1 is equal to mu2 into sin I2. Now students, condition for no refraction. Condition for no refraction. There is a 2 point. First, when light ray strike normal, there is a no refraction. In this case, angle of incidence is equal to 0. Is not 90 degree, is not 90 degree, angle of incidence is 0. Second point, when light passes without any deviation, either medium is rarer or denser or denser or rarer, it is possible only one situation when mu1 is equal to mu2. When the refractive index of two medium is same, light will not deviate. It passes without any deviation from one medium to another medium. Okay. Okay students, हम लोग लर्न करते हैं कि जब लाइट रेयर से डेंसर जाती है, it bends towards the normal. Our denser to rarer bends away the normal. How do we understand mathematically? And now the use of laws of refraction. Suppose this is a denser medium, this is the rarer medium. By concept, light will move away from the medium. This angle is I1, this angle is I2, suppose given. Question comes, when the light is passing from denser to rarer, why it bends away the normal? Prove that. Yeah, how do we understand? Look here. आपको याद रखना है हमेशा, whenever light is deviated from one medium to another medium, without asking any question, use this law, mu1 sin I1 is equal to mu2 sin I2. Okay. Put here, this is the mu d, sin I1 is equal to mu r sin I2. Sin I1 sin I2 is equal to mu r upon mu d. Now we can write here Vd upon Vr, because mu is equal to C upon V. By the first concept, we know that speed of light is always greater in rarer medium. The denominator is greater than the numerator, so its value is always less than 1. Therefore, we can write sin I1 less than sin I2. So I1 less than I2. Now after doing mathematical calculation, you'll get here the result I1 less than I2. Look here the blackboard, I1 less than I2. It means when light is passes from denser to rarer, it bends away the normal. Similarly, you can prove when light is passing from rarer to denser, it bends towards the normal. Okay, students. Now the next concept is in refraction at a plane surface. There is a big confusion, the role of mu. Always you remember, mu means mu d upon mu r. This is the landmark. Always you remember. It means light is passing from rarer to denser, rarer to denser. Always you remember. If light is passing from denser to rarer, you can write 1 upon mu. The application of this one is very important, and in your textbook or in numerical, if absolute refractive index is mentioned, is it okay? Otherwise, always it is given by mu is given means relative refractive index. Mu is given that relative refractive index. Okay. Now students, I am taking another very interesting topic. ये दिखने में तो बहुत आसान लग रहा है, लेकिन बहुत conceptual है, very conceptual, and many numericals based on this topic. That is, topic is the real depth and apparent depth. Real depth and apparent depth. It is divided in two cases. Case first, object in denser medium and observer in rarer medium. Object in denser medium and observer in rarer medium. This is the first case. In this case, the two possibility comes out for normal vision Normal vision means, I am taking one example. Students, suppose this is water. This is the object. This is the water. This medium is air. Rays always comes from the object. And for the image formation, you should take always only two rays. One from normal to the surface, like this, This is for the normal vision, the next ray very near to the normal, like this. When immediately draw a normal at this point, this angle is I. Light is passing from denser to rarer, it bends away the normal. Refract, these two refracted rays will meet or appear to meet. At that point image will be formed. It never will meet, it appear to meet like this. Image will form at this point. This angle is R, this angle is I, this angle is also be R. Let it, this point is A, this point is B. Okay. I am now doing the proof for this sales question. Before starting the proof, what is the real depth? D real and D apparent. The distance between object and free surface OA is real. Apparent means distance between image and free surface is apparent depth. Always you remember. Because light is deviated, so use Snell's law. Mu1 sin I1 is equal to mu2 sin I2. Angle is already very small, so we can write in place of sin I is equal to tan I is equal to, tan means perpendicular upon base, AB upon OA. AB upon OA means mu1 means mu D into, in place of sin I1 means AB upon OA is equal to mu R AB upon IA. So IA upon OA is equal to mu R upon mu D. मैंने आपको पहले ही बता दिया था व्हाट इज द म्यू. म्यू डी अपॉन mu R, and this is mu R upon mu D, so we can write here 1 upon mu. By this concept, what is the IA? Apparent depth, real depth upon mu. This is the first relation established. Apparent depth is equal to real depth upon mu. After this, students, what is the normal shift? Normal shift means OI. OI means OA minus IA. OA means real depth minus apparent depth is equal to real depth minus apparent depth means dr upon mu, so is equal to This is the formula of the normal shift. Real depth in bracket 1 minus 1 upon mu. This is a relation between the real depth and apparent depth. This is the formula of the normal shift, and this is the concept of the light is passing from object in denser medium and observer in rarer medium. Is it clear, everyone? Question comes, suppose we are taking here different liquids of refractory different. Mu1 depth is T1, mu2 its depth is D2. D2 means like this. Mu3 depth is D3, so on. Then for this type of the question, what is the formula of the refractive index? Mu is equal to real depth upon apparent depth. Real depth is this, means D1 plus D2 plus so on upon apparent depth means D1 upon mu1 plus D2 upon mu2 plus so on. With the help of this result, you can find the refractive index when any container containing different type of the liquids also. Second point, for oblique vision means this is the object and you are looking from this end. How to construct the ray diagram? This is the normal. Light is passing from denser to rarer away. Image will form at this position. This is the height h. Let it, this is the A, and this is the B. This height is capital H, this is the small h. When I am taking the example, suppose हम लोग खड़े हैं स्विमिंग पूल के एक एंड पर, एंड नाउ वी आर वाचिंग द बॉटम ऑफ द स्विमिंग पूल फ्रॉम द अदर एंड, कॉर्नर पे देख रहे हैं, तो वी विल फाइंड उस एंड पर स्विमिंग पूल एकदम गहरा ही नहीं है, उसका बॉटम एकदम ऊपर उठ के चला आएगा. It raised because due to the oblique vision, इसकी depth, this is the object, continuously ऐसे increase करती जाएगी. This is the like this. Like this. For this situation, formula of this, H is equal to capital H upon mu, mu cos theta upon mu square minus sine square theta under root 2 whole square. This is the h, small is the apparent depth, capital is the real depth, theta is the oblique vision. Theta is the oblique vision. How to verify this result? With the first case, for the normal vision, theta is equal to 0 degree. Means h is equal to capital H upon mu. Mu cos 0. Cos 0 means 1 upon mu square minus sine square 0. Sine square 0 means 0 under root 2 whole square. Small h is equal to capital H upon mu. Square of the mu square is mu. Mu is cancelled into 1. Means h is equal to capital H upon mu. This is the first case result. Small is apparent depth is equal to real depth upon mu. So this is the general formula. With the help of this formula, you can calculate. Suppose the question comes in the different competitive examination, what is the apparent depth if the observer is looking object 30 degree with the normal. 30 degree with the normal. So theta is equal to 30 degree. Observer looking the object which lie in the denser medium normally, means theta is equal to 0 degree. This is the first case. With the help of this, you can calculate many numerical problems. Similarly, case second, object in rarer medium and observer in denser medium. Object in rarer medium, observer in denser medium. The best example of this thing, when we are looking any flying object from the surface of earth, like this. This is the object. To one ray, normal to the surface. Second, near to the normal. Draw here the normal. It passes from rarer to denser. It bends towards the normal. At this point, image will form. This is A, this is B, this angle is I, this angle is R. This situation is the reverse of the first case. D apparent is equal to mu into D real. Normal shift. Normal shift means OI. OI means AI minus OA. OAI means D apparent minus D real. D apparent means mu D real minus D real is equal to mu minus 1 D real. This is normal shift formula in this situation. Is it clear? Now students, main implement is important things. What is the, how do we implement these real depth and apparent depth in numerical problem? I am taking the very good example. With the help of this, you can understand the concept of the real depth and apparent depth. Please pay attention. This is the water and this is the air. At any instant, a fish, actually question is this, fish is moving toward the surface of water normally. Fish is moving towards the surface of water normally, and the same moment a kingfisher, it is a type of bird which catches the fish. A kingfisher moving vertically downward. Kingfisher moving vertically downward. Okay, I mean fish is moving towards the upward normally and bird is moving vertically downward. The two possibilities is there. First possibility, suppose fish is observer and bird is object. ध्यान से सुनिएगा, fish is observer, bird in object. This situation is like in the second case of the real depth and apparent depth. So this is suppose y, this is x. Observer in denser medium, object in rarer medium. So observer will see as a greater height with respect to the real position of the bird. So this is the image of bird and this one is the mu y. Suppose this distance is h. H is equal to x plus mu y. ऑलरेडी मैं आपको ये फॉर्मूला बता चुका हूं. डिफरेंशिएट दिस इक्वेशन विद रिस्पेक्ट टू t. dh upon dt is equal to dx upon dt plus mu dy upon dt. I am taking only the format. Now clear your concept. What is the dx upon dt? It is the actual velocity of fish. dx upon dt, actual velocity of fish. dy by dt, actual velocity of bird. dh upon dt, it is the apparent velocity of the bird. Mu is the refractive index, and what type of refractive? Absolute? No, it is a relative refractive index. Okay, it depends on the data. Whatever value is given, you can solve with the help of this relation problem. Suppose fish is rising upward 3 meters per second. So what is the given? dx upon dt is equal to 3. Bird is diving vertically. So dy by dt is given suppose 5 meters per second. Then what is the and mu is given 4 by 3. Then dh upon dt is the apparent velocity of the bird. Apparent velocity of the bird you can calculate easily. क्वेश्चन इतना आसान नहीं है. क्वेश्चन के ट्रिक के पीछे जाइए, कैसे कैसे को सॉल्व किया जाएगा, इस चीज को समझिए ध्यान से. ओके, सिमिलरली यू कैन चेंज. नाउ फिश इज ऑब्जेक्ट, bird is observer, is the first case of the real depth and apparent depth. Okay, I am taking one more example. I think then you can understand better. Suppose this is a mirror, polished surface. Okay, this is the object. Its depth is h. Where image will be formed? Just behind the mirror. We know that. But in the same question, suppose this is the water, this is the bottom, this is the object, h distance, h distance, from the bottom surface. Okay, where its image will be formed? If we place d depth of water, it is a total reflecting surface, object is this, calculate the position of image of this object with respect to AB, with respect to AB. This question is for you. The next video I will discuss with you in detail. इसको आप ध्यान से देखिए, बाकी अगले वीडियो में मिलेंगे, तब तक के लिए नमस्कार।